Graph Theory Class 13 Video 4. In this video we're going to continue talking about the travelling salesman problem. In particular we're going to talk about another algorithm for trying to solve the travelling salesman problem. This time the algorithm is called the sorted edge algorithm. So this algorithm is going to be very similar to the nearest neighbour algorithm which we spoke about in the previous video. Again, the sorted edge algorithm is going to be a heuristic algorithm. So that means that it's not guaranteed to give you the best answer to the travelling salesman problem, but it gives you a pretty good answer. Okay, so it's not guaranteed to always give you the minimum length Hamiltonian circuit, but most of the time it gives you a pretty short Hamiltonian circuit. So let's just dive straight into the definition. So here we go. Definition: the sorted edge algorithm, which I just denote SEA. How does it work? The first step is you choose the shortest edge on the graph. That's easy enough. The next step is you choose the next shortest permissible edge. And I'll mention more about what I mean by permissible in just a second. The third step is you simply repeat the second step until you have a circuit containing all of the vertices. So what do I mean by permissible? Well, I say that an edge is permissible if it does not create a closed circuit without visiting every other vertex. So if you start adding edges, you're not allowed to add this edge here because then this vertex down here is left out. So you're not allowed to do that. Okay? And or the edge does not touch a vertex which already touches two previously selected edges. So by that I mean, if I draw a picture like this, if you've already selected these two edges, you're not allowed to select that edge, because then this vertex simply has too many edges coming out of it. You can't have a circuit with three edges coming out of a vertex. Okay? So let's see this algorithm in practice. I think the most confusing part of this algorithm is this notion of what's a permissible edge to select. But once you start doing a couple of examples, it will all become clearer, maybe. So, apply the sorted edge algorithm to the following graph. This is the same graph that we looked at last time, okay? So unlike the nearest neighbour algorithm, there is no starting vertex. You simply look at all of the edges and you choose the smallest one. Well, there's an edge of length 1 right here. So that's the shortest edge, so I'm going to choose it. Okay? Next, I look for the next shortest edge, and it doesn't need to be connected to the edge I've just drawn. It can be anywhere. So there's a 3, there's a 4, there's a 6, there's a 2. 2 is probably the shortest, so I draw this edge right here. Okay? And this edge is perfectly permissible. Okay? Now I continue in this fashion. So I look for the next shortest edge, which is probably going to be this 3. So this is perfectly permissible, so I draw it like that. Now I look for the next shortest edge. Well, the next shortest edge is this 4, but this edge here is not permissible because this vertex already has two edges coming out of it. If I add this red edge to that, then it has too many edges. So even though 4 is the next smallest number, it's not a permissible edge, so I don't add it. So I'm not allowed 4. How about 5? 5 is the next smallest number, and yeah, there's nothing wrong with 5. 5 I can add just like that. Okay. The next shortest number is 6, and this edge here creates a closed circuit, but that's okay because I've already visited every other vertex. So creating the closed circuit is okay now because I've been everywhere. So this is the output of the algorithm. And you can write it down however you want. You can write it down as A, B, C, D, E, A. Notice when you choose to write down the answer, there's some ambiguity about where to begin, but it doesn't matter. Like if you wrote this down as C, B, A, E, D, C, it's the same thing and you'd still get full credit. Okay. If we work out the total weight of this up here, then what do we get? 2 plus 5 plus 3 plus 1 plus 6, which is 17, which is a pretty good Hamiltonian circuit. It's pretty short. Okay, so this is the sorted edge algorithm. I have a hard time saying this, I'm sorry. Okay, that's the end of this example. That's the end of this video, and that's the end of this module.